3 years have passed since NASA's James Webb Space Telescope embarked on its mission to explore the universe's earliest epochs. The James Webb begins a journey backward to the universe's birth. Imagine someone proposing the creation of a telescope capable of observing back to the Big Bang, an astonishing concept, and peers through the depths of time to help scientists comprehend how planets, stars, and galaxies form, what occurs when they perish, and everything that lies between. It has been an extraordinary journey that has yielded some of the most stunning images humanity has ever witnessed. This is what the James Webb Telescope has revealed thus far. This is known as the Sombrero Galaxy. Unlike visible light imagery that displays only the galaxy's luminous core, Webb's mid-infrared instrument exposes a seamless inner disk and elaborate clusters within the outer ring. It still doesn't resemble a hat to me, but it is impressive. Astronomers have identified an extraordinarily voracious black hole at the heart of a dwarf galaxy from the early universe, dating to roughly 1.5 billion years following the Big Bang. Using James Webb data, the team found that this supermassive black hole is devouring matter at a rate exceeding 40 times what we believed was achievable. This intense accumulation, though presumably temporary, offers crucial insights into the swift growth of supermassive black holes in the early universe. James Webb and the Hubble Space Telescope have delivered this remarkable image of Vega, among the most brilliant stars in the night sky. Hubble's observation uncovers an extensive uniform disk of delicate dust particles, while Webb's infrared imaging identifies the radiance of warm dust in the disk's peripheral regions. Curiously, this disk contains none of the clusters or gas normally linked with large planets, meaning Vega exists in solitude out there, with merely rocks surrounding it. This composite image merges Webb's mid-infrared data with Hubble's ultraviolet and visible light observations, exposing elaborate details of these two spiral galaxies engaging with one another. The brilliant colors in the image emphasize regions abundant in dust and gas, crucial components for star formation. This is Centaur 29P, a massive rock and ice orbiting between Jupiter and Neptune. And what James Webb has documented here is essentially a colossal asteroid expulsion. Using the near-infrared spectrograph, Webb identified 2 carbon dioxide jets and 1 carbon monoxide jet erupting from 29P's surface here. We observe an atypical galaxy situated approximately 1 billion years after the Big Bang. The peculiar aspect of this galaxy is that its gas outshines its stars, a phenomenon rarely witnessed. Researchers propose that this could signify a transitional phase in galactic evolution, connecting the universe's first stars with more mature galaxies. This is a pair of galaxies colliding with each other, located 465 million light-years distant in the constellation Leo. The interaction encompasses a spiral galaxy and an elliptical galaxy, with the spiral's arms exhibiting distortion due to the gravitational forces imposed by the elliptical companion. James Webb has studied the Milky Way's outer edge, termed the extreme outer galaxy. Employing its near-infrared camera and mid-infrared instrument, Webb obtained detailed images of star-forming zones within 2 molecular clouds. These observations disclose the existence of young massive stars and complex formations of gas and dust at the galaxy's periphery. This is a galaxy that resembles a cosmic question mark. The phenomenon originates from gravitational lensing, where the tremendous gravity of a galaxy cluster warps and amplifies the light from a more remote galaxy, producing this question mark configuration. Initial observations from James Webb disclosed massive, extraordinarily bright galaxies present merely 500 to 700 million years after the Big Bang. These early galaxies seemed excessively large and luminous for their age, implying an unexpectedly swift formation. New research indicates that supermassive black holes at the centers of these galaxies likely contributed substantially to their brightness. The powerful radiation from these black holes would render the galaxies appearing more massive and brighter than their actual state. This is a gas giant exoplanet several times Jupiter's mass, positioned approximately 12 light-years from Earth. With an estimated temperature of about 35 degrees Fahrenheit or 2 degrees Celsius, this ranks among the coldest exoplanets ever directly observed. That's not to suggest there aren't colder planets. It simply means we're now capable of detecting objects in the galaxy that aren't blazing hot stars, which is quite remarkable. This is a planet where one hemisphere perpetually experiences sunrise and the other eternally witnesses sunset. Utilizing Webb's near-infrared spectrograph, Astronomers detected a temperature difference of approximately 300 degrees between the two hemispheres. Any speculation on which was hotter? I would have predicted morning, but it proves the sunset side is the hottest. To commemorate its second anniversary, James Webb captured a magnificent infrared image of these two interacting galaxies situated approximately 326 million light-years away in the constellation Hydra. This galactic pair are designated the Penguin and the Egg. Their continuous interaction, initiated between 25 and 75 million years ago, has produced substantial distortions in their structure, with one's spiral arms extended into a form reminiscent of a penguin embracing an egg. This is a protostar, fundamentally a nascent star in its preliminary formation stages before nuclear fusion commences. The image displays a luminous hourglass-shaped structure resulting from the protostar's outflows engaging with surrounding gas and dust. A dark, slender disk of dust bisects the hourglass's center, channeling material into the developing star. This is a pioneering image of the Serpent's Nebula, exposing multiple pairs of bipolar jets from newly forming stars. These jets manifest as red streaks radiating from protostars and align intimately with the surrounding gas and dust filaments. The alignment corroborates existing theories that magnetic fields fulfill a vital role in guiding both the jets and the filaments during star formation. The Crab Nebula is essentially remnants from a supernova positioned 6,500 light-years away in the constellation Taurus. Utilizing its near-infrared camera and mid-infrared instrument, Webb captured detailed images disclosing the nebula's intricate structure, including filaments of gas and dust alongside regions of active star formation. This is a pair of twin infant stars formed merely 2 to 4 million years ago. The discovery was enabled by Webb's mid-infrared instrument, which also identified gas jets emanating from both stars. These are three of the universe's most ancient galaxies, dating to between 400 and 600 million years after the Big Bang, and they remain actively forming stars. They accomplish this by drawing in cold helium and hydrogen gas from their environment and fusing the elements to ignite new stars. James Webb has furnished new insights into WASP-107b, a gas giant exoplanet recognized for being puffy like a marshmallow. Observations disclose a considerable deficiency of methane in its atmosphere, indicating that the planet's interior is substantially hotter and its core is more massive than previously calculated, thus explaining its puffy appearance. James Webb has quantified the wind speed on a gas giant exoplanet located approximately 280 light-years from Earth. These observations reveal that the planet, which maintains one side perpetually facing its star, undergoes extreme temperature variations between its day and night sides. This generates high-velocity equatorial winds estimated at speeds reaching 8,000 kilometers per hour, which assists in redistributing heat across the planet. This is the sharpest infrared image to date of the Horsehead Nebula. I still don't perceive a horse, but the observations expose intricate details of the nebula's so-called mane, demonstrating complex interactions between gas and dust. This is a starburst galaxy positioned 12 million light-years away in the constellation Ursa Major. The starburst is undergoing a high rate of star formation, generating new stars at a rate 10 times faster than our own Milky Way. James Webb has identified complex organic molecules, including alcohol, in the frozen regions of a molecular cloud. These findings indicate that alcohol was present during the early phases of star and planet formation, potentially contributing to the establishment of life-supporting environments. This is a massive star-forming region of the Triangulum Galaxy, situated approximately 2.7 million light-years from Earth. This region harbors over 200 young massive stars, all in the initial stages of their development. We are observing one of the brightest and most distant known galaxies, existing merely 430 million years after the Big Bang. James Webb has supplied compelling evidence for the presence of a neutron star at the core of a supernova. This supernova, first witnessed in 1987, has been thoroughly studied, but the nature of its core remained uncertain until now. Researchers analyzing data from James Webb have determined that many early galaxies resemble pool noodles or surfboards. This is a dust cloud that resembles a cat's tail. Astronomers using James Webb have detected an aurora above the north pole of a solitary brown dwarf located 65 light-years from Earth. This finding suggests that the aurora, similar to Earth's northern lights, may be heating the upper atmosphere of the star. Unlike planets, brown dwarfs lack a host star to drive these atmospheric phenomena, indicating that the light is produced by the brown dwarf's own magnetic field interacting with ionized gas in its environment. James Webb has been directed at Uranus and its observed phenomena. The near-infrared camera revealed 11 of the planet's 13 known rings, including the faint Zeta ring, demonstrating Webb's sensitivity to such delicate structures. This is a high-definition image of what remains following a supernova. The near-infrared view exposes intricate details of the expanding shell of material from the exploded star, including bright pink and orange clusters composed of elements like sulfur, oxygen, argon, and neon. This is a Herbig-Haro object, a luminous region surrounding a newborn star or protostar. Herbig-Haro objects form when jets of gas from protostars collide with nearby gas and dust at high velocities, generating shock waves. WST has disclosed unprecedented details of our own galaxy's core. Utilizing its near-infrared camera, Webb's observations disclose approximately 500,000 stars, along with previously unidentified features like these extraordinary blue needle-like structures. Here we have another collaboration between James Webb and Hubble to produce this vibrant, comprehensive image of a galaxy cluster. By combining Webb's infrared observations with Hubble's visible light data, this panchromatic view encompasses wavelengths of light that are nearly imperceptibly small, revealing a vivid landscape of galaxies. Here we have discovered an unknown high-speed jet stream in Jupiter's atmosphere. This jet stream, situated above the planet's equator and spanning over 4,800 kilometers in width, displays wind speeds reaching 515 kilometers per hour. Positioned approximately 40 kilometers above Jupiter's main cloud decks, this discovery provides new insights into the complex atmospheric dynamics of the gas giant. Carbon dioxide has been detected by James Webb on the icy surface of Jupiter's moon Europa, specifically in the region designated as Terra Regio. This finding suggests that carbon likely originates from Europa's subsurface ocean rather than external sources like meteorites, and carbon is an essential building block for life. This is Earendel, the most distant star ever detected, located in the Sunrise Arc galaxy, 28 billion light-years away. Utilizing its near-infrared camera, Webb identified Earendel as a massive B-type star more than twice as hot as our Sun and approximately 1 million times brighter. The star's light, emitted within the first billion years after the Big Bang, has been magnified by gravitational lensing, permitting this unprecedented study. This is a galaxy cluster commonly designated as El Gordo. The immense gravitational field of El Gordo functions as a lens, distorting and magnifying the light from background galaxies, resulting in prominent gravitational arcs. This is another Herbig-Haro object created by a pair of actively forming young stars located approximately 1,470 light-years away in the constellation Vela. The image reveals intricate details of the star's bipolar jets, which have been expelling material in opposite directions for thousands of years. These jets interact with surrounding gas and dust, creating shock waves that produce these vibrant colors. James Webb has detected water vapor in a distant solar system, and it's located within 100 million miles of the host star, the region where rocky planets like Earth typically form. This is the first occasion water has been observed in the Goldilocks zone of a disk already known to host 2 or more protoplanets. To commemorate its first anniversary, James Webb captured a detailed image of this cloud complex, the closest star-forming region to Earth. This high-resolution image reveals numerous protostars and their energetic jets interacting with surrounding interstellar gas, illuminating molecular hydrogen in red hues. These are 2 dusty supernovas, exceptionally dusty. These findings substantiate the theory that exploding stars significantly contribute to the dust content observed in early galaxies, enhancing our understanding of cosmic dust production and distribution. James Webb has discovered a space web comprising 10 galaxies, dating to approximately 830 million years after the Big Bang. This early cosmic web formation offers insights into the universe's large-scale structure and the role of gravity in shaping matter distribution. This is a detailed infrared image of the barred spiral galaxy, situated approximately 20 million light-years away in the constellation Virgo. This observation highlights the galaxy's central bar structure, composed of stars funneling gas toward its core, thereby fueling star formation. We have detected a massive water vapor plume emanating from the southern pole of Saturn's moon Enceladus. This plume extends over 9,600 kilometers, making it 20 times larger than the moon itself. The observation provides direct evidence of how Enceladus's subsurface ocean contributes water to Saturn's entire system, including its rings. James Webb has provided an unprecedented view of a mini-Neptune exoplanet located approximately 40 light-years from Earth. Observations reveal a highly reflective atmosphere, likely composed of a thick layer of clouds or haze. The planet's atmosphere appears to contain significant quantities of water vapor, suggesting a steamy environment. This is a super-bright infrared galaxy created by the merger of two spiral galaxies positioned 250 million light-years away in the constellation Serpens. This is the nearest ultraluminous infrared galaxy to Earth. The collision, which commenced about 700 million years ago, has triggered an enormous burst of star formation, with approximately 200 massive star clusters concentrated in a region spanning 5,000 light-years. We have captured new details of Cassiopeia A, the youngest known supernova in our galaxy, located approximately 11,000 light-years away in the constellation Cassiopeia. The high-resolution infrared imagery reveals intricate structures within the expanding debris field, including bright knots of material and diffuse emissions, offering new insights into the aftermath of stellar explosions and the processes of element dispersal in the universe. James Webb has measured the dayside temperature of TRAPPIST-1b, a rocky exoplanet located approximately 40 light-years from Earth. Using the mid-infrared instrument, scientists determined the planet's dayside temperature to be about 232 degrees Celsius. This high temperature suggests that TRAPPIST-1b lacks a significant atmosphere to redistribute heat from its star, indicating a barren rocky surface. This is a star that's about to explode. Wolf-Rayet stars are massive, bright, and short-lived, with only a relatively brief existence before detonating in a supernova. This is a deep field image of Pandora's cluster, revealing three massive galaxy clusters merging into a megacluster. This merger creates a powerful gravitational lens, magnifying more distant galaxies and offering insights into the early universe's structure and evolution. This is an asteroid measuring between 100 and 200 meters in length that resides within our main asteroid belt between Mars and Jupiter. It's nothing exceptional. It just demonstrates that James Webb can observe relatively small objects in our solar system, like asteroids that might someday impact Earth and destroy an entire city. So that's reassuring to know. This is the dusty disk remaining when planets collide. The observation utilizes Webb's near-infrared camera and marks the first occasion this disk has been imaged at these infrared wavelengths, revealing its inner regions with exceptional clarity. Here we have a dynamic star-forming region positioned 200,000 light-years away in the small Magellanic Cloud. The near-infrared camera aboard Webb revealed an abundance of dust and hydrogen clouds, which are essential building blocks for the formation of stars and planets. James Webb has unveiled previously concealed jets and outflows from young stars within the cosmic cliffs of the Carina Nebula. Utilizing its near-infrared camera, Webb detected molecular hydrogen, a key star formation ingredient, illuminating the early stages of starbirth. Here we have the intricate structures of the Southern Ring Nebula, which are the result of interactions involving at least two, possibly three, previously unseen companion stars. By combining Webb's infrared imagery with data from the European Space Agency's Gaia Observatory, researchers have determined the mass of the central star before it expelled its outer layers to form the nebula. This multi-star interaction has produced the nebula's distinctive oblong and curved shapes. James Webb has captured a haunting mid-infrared image of the Pillars of Creation, a star-forming region within the Eagle Nebula. Unlike previous images, this view emphasizes the intricate structure of the interstellar gas and dust without capturing starlight. This is a cluster of massive galaxies forming around an exceptionally red quasar from 11.5 billion years ago, which is a young active galaxy shrouded in cosmic dust, giving it a red color. The discovery offers insight into the early assembly of galaxy clusters and the development of the cosmic web. Here we have an image of at least 17 concentric dust rings surrounding a binary star system. Look familiar? These rings form every 8 years as the two stars approach each other in their elliptical orbits, causing their stellar winds to collide and compress gas into dust. The resulting dust shells expand over time, creating a pattern reminiscent of tree rings or a fingerprint, each marking a specific period in the star's orbital history. James Webb and Hubble teamed up again to capture detailed observations of NASA's double asteroid redirection test impact, marking the first instance of both telescopes simultaneously observing the same celestial event. The DART mission involved intentionally colliding a spacecraft with a small asteroid to test planetary defense strategies. James Webb has provided the clearest view of Neptune's rings in over 30 years. The near-infrared camera captured distinct images of the planet's narrow rings and fainter dust bands, some of which haven't been observed since Voyager 2's flyby in 1989. The images also reveal 7 of Neptune's 14 known moons, with Triton appearing particularly bright due to its icy surface reflecting substantial sunlight. Here is one for the arachnophobes, the Tarantula Nebula. Webb's near-infrared camera has revealed tens of thousands of previously unseen young stars, providing unprecedented insights into early stellar development. And lastly, here is a detailed infrared image of the Cartwheel Galaxy, located approximately 500 million light-years away in the Sculptor constellation. This rare ring galaxy, formed by a high-speed collision between a large spiral galaxy and a smaller one, features a bright inner ring and an expanding outer ring, both sites of intense star formation.